So I'm Anand Srinivas. I'm the CTO and co-founder, one of the co-founders at Nyansa. I have with me our head of analytics, Murtaza Zafar, as well. So any of the really hard questions are going to go to him. But in the meanwhile, I'll try and wave my hands and give you guys some kind of story about the company and what we've done, as well as some of the new stuff that we've recently released. First thing I also should say, this is not about white box switching or white box, all that. So I guess it's a changeover from yesterday. But let's definitely keep the session really interactive. We have a lot of time, as Tom said, 2 hours. So let's fill it with a lot of great questions and interaction. So, attacking last hop user performance. So if I just step back for a sec, Nyansa is the company, Voyance is the product. And the product Voyance, we've been shipping it for a little bit more than 2 years now. And what Voyance focuses on is user experience of client devices in networks. So we focus on the access network side of the space. So we look at every single client device in your environment and look at that client's user experience when it connects to the network over wireless. It gets authenticated with Radius, gets an IP address with DHCP, goes through DNS, gets onto the WAN network, gets onto the internet, and then accesses applications. We're looking at that end-to-end flow for every single client device in the environment. And then what we do is, the buzzword of the day, analytics, right? Machine learning, all that good stuff, where we take the user experience that we measure for every single client device in the environment, and we find patterns with it, and we try and predict, we try and make recommendations to you. And in the process of going through the presentation, I'll actually show you guys in the product, because that's the best way to do it rather than just sort of bore you with slides. But the initial set of slides that I'm going to go through are really going to focus on two of the recent data sources and analytics we've kind of added to the product. And in particular, those are looking at the client to the access point from the client side perspective. We've added another data source into the product that just focuses there. And we've also added NetFlow data from routers in order to take into account the user experience on the WAN side of the house. And that's something we just released about a month ago. And so, I'm pretty excited to talk to you guys about that. So, starting up, as I said, the two new releases that we've done recently is adding, something we've called the client agent. So this is software that goes on actual client devices, and I'll talk about that in more detail, as well as processing NetFlow data and giving insight into the WAN side of user experience as well. And after these two sources, really Voyance is the only end-to-end solution that sort of looks at client user experience and correlates across the client, the wireless, the connectivity, the network services stack, the internet or the WAN, as well as the application, right? That sort of end-to-end visibility on every single client device, whether that's a Mac or a laptop or a phone or anything like that, or whether that's an IoT device like a bedside monitor or an infusion pump at a hospital. So just a bit of a refresher of the overall platform. And how it works, the deployment, and what we do. So we sell to enterprise IT, and what we give enterprise IT, the first piece of it is this piece down here we call the crawler, which is something we put on site at an enterprise, and its job is to collect data from the enterprise about user experience. And so all of the data sources that we collect today are sort of listed out on the left over there. So we collect data from the wireless controller, right? So we use SNMP and other protocols to talk to Cisco, Aruba, Extreme Networks, those wireless controllers, and get data about every single client's wireless state from that. We collect packet data, right? So you can point a span port at the crawler, or a mirror or a tap. We analyze those packets to give us a different perspective, the wired perspective, on user experience and applications and protocols and things like that the clients are going through. We process NetFlow data from routers, and I'll get into that in more detail, but that can be pointed to the crawler as well. We process syslog data from different servers. So on the Radius server side, for example, we support ClearPass, Aruba's ClearPass, Cisco's ICE, Microsoft Radius, FreeRadius, all of these different systems, and the syslog coming in there to sort of correlate that data as well. We're going to be adding DNS and DHCP to this as well, and other kinds of integrations. We also process data from applications, certain mission-critical applications that actually have extra sort of ground truth data about the user experience on that application. So an example of this is Skype for Business. So Skype for Business has an API that gives us data about these two clients had a call, or they had a conference call happen. This was the stream quality or the MOS score. This was the exact user experience of these clients. And that's something we can take and then correlate that with everything else that we're getting. Other applications, like in certain verticals, like hospitals, there are clinician communication devices like ASCOM and Vocera and things like that. We can get data from those applications as well that tell us what's going on.
I may have missed it. Do you have integrations with Infoblox or Blue Cat or?
Not yet.
Okay.
So that's next on our list. So we started with Radius and syslog from the different Radius vendors, and the idea next is DNS and DHCP to do, precisely that. Yeah, so in verticals like healthcare, whether it's clinician communication devices, even bedside monitors, to get sort of the application side, where application means something very different. The user experience, quote unquote, of a bedside monitor has to do with whether the waveforms, like heart rate, blood pressure, and all that, are getting to the viewers that are viewing them. And so when we can get data like that, that tells us the ground truth of the user experience there, and we can correlate it with everything else that we have. So we can take data there. And then finally, what we've added, the other data source we've added, again, all of these data sources are optional. I'll talk about that in a sec, but is client agent data. So today we support Microsoft, Android, and Mac OS X, where you can put a piece of software on the client. That client can run synthetic tests. It can also collect wireless data from the client, and I'll get into more detail on this. But to us, this looks like yet another source of data to correlate with the rest of it. So, one way to think about, so the crawler's job is to collect all of this data, but outside of doing that, it doesn't do very much. It compresses, encrypts, and sends the data back to a backend. And the backend can either be hosted in the public cloud. Today we host in Amazon AWS, or it can be hosted in your private data center as well.
So is it collecting the data, or is it just the headers of the packets?
It's extracting metrics or metadata from the packets as well as all these other data sources that I talked about. And so, we would never send live packets over, a WAN link back to a cloud backend, or even a private data center backend for that matter. So we're just extracting metadata from it that tells us something about user experience. Okay. So this is the user, this is, his DHCP user experience, his, and this is the application he's using and user experience and so on.
Does it collect anything on the RF itself, or just the packets?
No, definitely. So in order to say anything about the access network, in today's day, in 2018, you have to say something about wireless. That's the primary problem on that side. And so the wireless controller is telling us a whole bunch of RF data around, this is the signal of a client, or signal to noise ratio, the access point is connected to, it's the noise, the interference levels that we see. And on the client agent software, you can get RF data from the client perspective as well. So that's so there's sort of an infrastructure perspective of the wireless, and then there's the client perspective of the wireless, which is also an interesting thing that I'll get into. Yep.
So you're collecting data from a lot of sources.
Mm-hmm.
I imagine there's somewhat of a challenge of kind of like meshing all of this together to give you, because I see the angle you're going at.
Yeah.
It's this end-to-end visibility of being able to see not only from the client perspective, but from the application perspective, wherever it's hosted, and the infrastructure in the middle. Lining that all up, though, I imagine can be a challenge, especially as we talk about devices that are kind of changing identity for security purposes and those types of things. So what are some of the things you're doing there to ensure that's meshed, or is that something we're going to cover later?
I can talk about it a little bit right now. So, as an example, NetFlow data and looking at live packets. They come at different frequencies because different routers are sending data in different ways. But we need to join that data because we need to know that Well, when this client device went to, I don't know, office365.com, this is the router interface his traffic went over. And so when we think about application experience, we want to be able to tie that application experience to that router interface. And so we need to join those data sources. And so that's definitely an aspect of it, right? There's that. There's getting data from the wireless controller, which tells us this is the MAC address of this user, and this is his username, because the wireless has an integration into AD and things like that. But this is now where he is located. This is his IP address. So now we can take the IP address that we see on the wire and map it back to that MAC address to make sure that we're...
Is the MAC address the source?
The MAC address is the ideal source.
Right.
Absolutely.
So that's really what you're falling back to, is that this MAC address, and I'm looking for the IP that's associated with that MAC in the NetFlow tables. I'm looking for that in the syslog, the IP associated with that MAC at that particular time, and then you're just kind of keeping state on all of that.
Exactly, exactly. So the MAC address is the ideal unique identifier. In most cases, we get that with wireless clients because the wireless controller contains that data, as well as the mapping between MAC to IP, as well as to username. But in some cases, with wired clients, as an example, we'll only get the IP address as a unique identifier. So we'll use whatever we can get, right? The best kind of identifier. But it's definitely part of the big problem in terms of taking all these data sources, but making sure that the data that you're extracting and kind of lining up together all belongs to the same device so that you can actually extract meaningful insight from it. Yep.
Are you correlating that data? Mm-hmm. Okay.
Yeah, definitely. I mean, that's something I'd rather show you rather than talking about. But I'll talk about it a little bit here in the slides. But absolutely. So our biggest value prop is not in the collection of the data, right? It's really in the correlation and the analysis of the data and sort of the insights that come from that. And so I'll show you guys that. So, okay. So, yeah, as I said, so the back end, by the way, that's where all of Murtaza's magic happens in terms of we use a big data analytics platform called Apache Spark, and we're sort of crunching all of this data that's coming in and trying to extract those insights. So, all right. So hopefully that kind of gave everybody sort of a level set on what the product is at a high level, and like where sort of it fits into the architecture and into an enterprise network environment. So what I'm going to do next is I'm going to talk about, just because these are our most recent two releases, right, and sort of very different from last year, I'll focus on these two aspects of it, WAN and client agent. But then when I show you guys the product, I'll level set again and sort of show you all of the aspects of the product, and then show you guys the delta or the new stuff, what WAN and client agent as data sources have enabled in the product, and the ability to do that. Oh, sorry. All right. So let's start with WAN. What was the motivation why we decided, okay, incorporating NetFlow data and incorporating data from the WAN side is important. After talking to a lot of customers, the real problems on the WAN today, the way customers saw it, the change, if you will, about the WAN between now and before, is that people are going cloud, right? Or enterprises are going cloud. There are more cloud-based business-critical applications, but those cloud applications, or as users access those cloud applications, they're still traversing the same old WAN topology. Right, so this is the same kind of motivation for SD-WAN, you could say, right? In terms of traffic is following the same topology of branch to data center to application, and the question is user experience good, right? And how do I know when it goes over these interfaces or when it goes through these data centers or these service providers that the user experience is good to those applications? And it didn't matter in the past when people are just going to Facebook and things like that. But as Office 365, for example, moves to the cloud and is mission critical that way, or Salesforce.com, you need to make sure that all these things are working across the WAN as well. So that's one. Another one is the end-to-end visibility, right? The most common, when you have poor performance on your laptop or your device or any kind of device, really, the two most likely culprits, if it is going to be the network and not the device or the application, is probably the wireless and the internet, right? Either the internet is blocked up, or your wireless is poor. If it's going to be a network problem, it's probably not going to be a switch. It's probably not going to be on the LAN, but of course that could happen as well. But those are the two most likely culprits. So end to end, right? There's this sort of age-old problem of finger pointing when these problems happen. A company releases a new application, they host it in their data center or deploy it even in the public cloud, and performance is poor. Where's the problem? Is it the application? Is it the internet? Is it the wireless? Is it the device itself? And for us, we want to be sort of the ground truth there of saying, well, we've taken in data sources from everybody's domain. For the router guys, we've taken in NetFlow data. Right? For the wireless guys, we've taken in the wireless data. For anyone else, for the server guys, we've taken in server data as well. And so everybody sort of has a role at the table or data at the table that can get correlated to analyze this. So the next part of this is just like a WAN traffic argument. So big problems happen on the WAN when you have bursts, and the link fills up. Packets get dropped, and bad things happen. And what we've noticed in the past with WAN products that have existed is you have aggregates. You'll get a nice pie chart of these are the applications that are used. This is how much traffic each of them sent over the last hour or over the last week or whatever. And you can get sort of a very broad view of what's going on the WAN side. But the way we looked at the problem is actually when things happen, when bad things happen, they actually happen over a much shorter time period than that. In fact, there's even the sort of the microburst aspect of, they happen at the millisecond level or the microsecond level. We don't tackle that side of it, but at least where we sort of start is at a minute-by-minute granularity or a second-level granularity. Let's look at when the link is filling up, and let's look at who the culprits are in terms of whether it's an application or a particular source that's causing that, and sort of giving a summary of that, or correlating and analyzing that data on the WAN.
I'm just curious, I have a question, because having worked in the service provider space a few years ago, this concept of quality of experience came out to be a thing in service provider space, going down to the last mile.
Yep.
And so, enterprises weren't always traditionally structured like that. They were worried about applications being consumed inside the data center. Now it's you have enterprise users that are worried about consuming applications on the internet, and it's all about internet connectivity and performance. So it's very much the same thing and almost solving the same problem. So I'm just curious. Right. It almost seems like you guys, to coin a term if you haven't used it, you're like enterprise quality of experience. It's very much solving the same problem. I don't know if you guys have ever looked at those models of service provider QoE when developing this.
So it's interesting. There's service provider. There's the APM players in the data center, the application performance management players. Mm-hmm. Then there's sort of, what you're calling enterprise QoE, or, we've called user experience or whatever it is. But absolutely, it's kind of, the mirror element or like a related element of user experience, which in our mind has been neglected, right? So when we came into the space a couple of years ago, really the only players on the access network at the time were the network monitoring solutions, right? The SolarWinds, the Cisco Prime, the Aruba Airwaves of the world, or HP OpenViews and things like that. And that's it, right? There was nothing sort of looking at data sources or anything like that. All the sort of action in some ways was on the data center side with New Relic and App Dynamics and those players, or maybe on the service provider side with players there. And so we kind of entered this space and we're sort of like, well, actually nowadays with all like sort of the change in BYOD, IoT, wireless, if you're going to have an application problem, most of it is probably happening on the client side and happening on the access network side versus in the data center, where I think they've sort of figured things out pretty well. And so, yeah,
but I think you're right, because it's, it used to be, we put QoS and then it was quality service is really not nearly enough, because it doesn't matter if the end user has a poor experience and you're not able to help them understand why, then it doesn't really matter.
Exactly. And there's another new phenomenon, which is connectivity. If the user can't even connect to the network, then he's obviously having a poor user experience, but you're never going to see it either on the service provider or in the data center, right? Because it's sort of the tree that didn't fall or whatever it is, right? That he couldn't even connect to the network. And that's something, again, that's on an access network side versus elsewhere. But yeah, absolutely. So it's maybe history is kind of trending in that direction, or in terms of yeah, good call. So the last thing is, these are a little bit more traditional kind of problems of, okay, I'm spending a lot of money on my, private MPLS links or whatever across, my 1,000 sites. I'd like to know why I'm spending that money. Like, what are applications costing me, right? And, the problem there is it's not about aggregates or anything like that. It's about really in those peak minutes, what percentage of my WAN bandwidth is being taken up by a Facebook or by a YouTube or something like that? And do I really want that, right? Or do I want to enable policies or throttling or something like, or shaping that sort of can eliminate that? And so, again, that's another problem that's come up for us, or come up from customer, or talking to customers. And then the last is just proactivity, right? And I'll get into this as well. Proactivity is another one of those buzzwords of, let's be proactive rather than reactive and all. But it really does matter. I think traditionally, especially on the WAN side, it's been sort of a very reactive approach of everybody collects net flow data typically and has it in this repository or this big, data store. But you only really look at it either when there's sort of like a breach, like from a security standpoint, or you'll look at it if you're really trying to get down to granular, some flow or whatever that you want to look at. But it's all after the fact. It's not, you're not doing it proactively. You're sort of doing it very, very reactively in that way. And so that is an absolute sort of an important side of this. And scalability, right? Rather than just sort of process this all in a single box, right? As traditional, let's do this in a more, modern web scale way, where we have sort of horizontal scalability. If you need more capacity, add more capacity, and everything just kind of works. So,
quick kind of something that I've noticed is, how have you guys responded to, I think the WAN is transforming from traditional MPLS to SD-WAN, where we're really starting to encapsulate. A lot of the products that are on the market today, you go to a dashboard and you can see kind of centralized reporting straight from there. So if a customer was, looking to understand the user experience from a WAN perspective, what would steer them away from their dashboard to Nyansa?
It's the correlation at the end of the day, right? It's the fact that we're taking this data and, again, that's the siloed approach of, okay, the WAN guys think everything is fine because they're looking at their dashboard and everything is fine. But maybe it's some problem on the other side. It's the wireless, or it's, the application side where there's data there. And what we've found is that we haven't seen another vendor try and take all these different data sources on that side, whether it's from the WAN side. So regardless of SD-WAN or traditional WAN, for us it's the same. I mean, we just want to take the data of where the flow is actually going and how are those flows actually performing. And then we want to correlate that with all the other data sources and give sort of an end-to-end view that's correlated like that, versus sort of a siloed approach. So that's basically, that's the big value add.
So usually most of them are in the data center, or they're doing the WAN, or they're doing wireless, or they're doing, and not too many of them are full spectrum. So you can just send me some data and I'll work out what that means and correlate. So everybody mostly thinks of the WAN as separate from the data center, as separate from the wireless, as separate from the campus. But actually they're all the same. They're all just...
When you look at it from a customer experience, they're all the same.
There's some unique stuff about a wireless or an optical network associated with the layer 1. So you do have to have some minor extensions to cope with new data sets. But at the end of the day, an IP packet doesn't change, whether it's on the internet, on a wireless, on a switch, or in a data center, or in an SD-WAN overlay. And that's the value of Nyansa, is it's bringing it all together, not just data center. And we focused on scaling the data center. These guys can bring that end-to-end view.
Right.
Yep, exactly. So, cool.
This makes a lot of sense, especially as we were discussing earlier with the smaller organizations that may not have a data center.
Well, the smaller organizations don't need the scale. So most companies have over-invested in building these microservices scale-out engines. Well, that's fine if you're chasing after the Fortune 10, right? But most of us don't have a scaling problem. Most of us have an operational problem. And we don't also have the ability to run 5 different tools
True. But the smaller
Exactly.
organizations still kind of want that view
Yep.
without necessarily having that.
But I also only have one product. I don't want to have 5 products, one for this,
Right.
one for that, one for this, one for that.
Exactly. And that's one of the big things of you don't want yet another tool basically in the tool chest. Now at the end of the day, we're not sort of promising to solve, be the one-stop shop and replace everything, and you don't need anything else. But there is definitely an element of I want something to take in all these data sources. It's one of the reasons Splunk is popular, right? Not necessarily amongst sort of IT operations, maybe more on the security side. But it's sort of one spot to look at for all of these different logs and things like that, and search and the ability to search through them. And for us, one of the ways we also look at ourselves is, the Splunk value prop. When they built it, they had to build it proprietary, right? Nothing existed. Today, with Elasticsearch and those kind of like web scale technologies available, that stuff is open source that you can sort of integrate into your products. And so the value prop of just taking in logs and just indexing them isn't sort of good enough anymore. And so the tack we take is, all right, we're going to take in all this data, but we're going to actually analyze and correlate it together for that end-to-end view. And that's going to be our value prop sort of on top of that. And so,
are you finding any challenges? So as I hear this, I mean, this sounds fantastic, right? I mean, it does, right, to get a centralized view. But we have all these monitoring tools that never seem to check all the boxes, even when they're specialized in one function.
Yeah.
And now you're talking about doing, monitoring and analytics across multiple functions,
Yep.
right? And so, I guess the question is how are you executing on that in a way that's better than people who specialize in one particular function?
Yeah, I mean, the way we kind of put it is that we're never going to re-implement. Okay, so let's take a Radius server as an example. A ClearPass server has a UI and and a CLI and whatever else, and there's some very, very deep granular information there, which in certain really hairy problems, you're going to have to go there and really, really dive in, and that's just that. We're never going to be able to address that, every single use case. But what we are going to be able to do is, take an 80-20 approach of saying these are the most common problems, and these are the most common problems where there's a lot of finger pointing, and you don't exactly know where the problem is. And, the other side of it is, these are the kind of things where people don't necessarily know when things have changed or, have things measured and quantified. And we can kind of fill in that gap as well of detecting changes or detecting deviations, measuring, the overall performance and things like that, quantifying it, sort of giving insight into if you made a change, did things actually get better? Or, just anecdotally, do you feel, happier or whatever, right? And so those are the areas where we think we're adding a lot of value. But definitely at the end of the day, there's going to be a 20% or whatever it ends up being
Sure.
that we're just not going to be able to do.
I mean, you're acting as, a comprehensive but an overlay in bringing all this data together. The idea is that you'll be able to solve most of your problems here, but like you said, there's going to be times and opportunities where you're going to have to dig in deeper with individual logs. And I believe I asked this question last time I saw you. You mentioned, wireless controllers you worked with. All of them were on-prem.
Yep.
We're seeing a lot of cloud managed services, not just in wireless, but also in switching infrastructure and other types of services. What's your direction there? What are you guys doing to try to integrate that kind of data as well?
Yep. So, we're looking into Meraki support as an example. We do support Aruba Instant today. Okay. That's something we added, right? A controllerless architecture there. Cisco has a couple of other, Cisco has a lot of different products and architectures, and we support a lot of those as well. And so absolutely, we're seeing the same thing, that's happening. And so as these systems sort of have more and more data that can, as they sell to more and more enterprise customers, they have to, part of it is sort of the management and visibility and correlation. And that's where, as they develop, we step in and kind of take that data. So we've looked into other, Aerohive and Ruckus and stuff like that. But, our tack is generally, we're trying to focus on the largest market share and sort of go down the list. So, when it comes to DNS and DHCP, it's very likely we'll start with Infoblox and BlueCat, and then do the rest of them, just because the market share is so big. So the same thing is true on the wireless side. Yeah.
So I have a question for you. When I think about network analytics, there's a handful of use cases, or 2 handfuls. application dependency mapping, security, troubleshooting. What would you say your number one use case is for this product?
The number one use case is probably prediction, right? So, when it comes down to it and you deploy all of this, some people do find value. The power users are like, hey, I want to go down and sort of see all the raw data and see the details and stuff like that and react to everything. But a lot of customers are like, look, I'm giving you all this data. What I want at the end of the day are recommendations, right? You tell me what I'm supposed to do and how that's going to help me and make a prediction for me and then prove it, right? Prove that it actually worked. That at the end of the day is sort of the holy grail of we have a lot of aspects in the product that I'll show you guys that achieve that, but deeper and deeper on that side is the real holy grail of network analytics. It's really to a point where, in an ideal world, this is a little bit of a tangent, but the folks that have really done network analytics well are the consumer folks, the Googles, the Netflixes, the Facebooks, and whatever. And you won't see anything in any of their UIs or whatever about analytics. Like you'll never see the word machine learning somewhere on Google Maps, right? It happens under the cover somewhere, and what you're presented with is the action or the benefit to your day-to-day life. And really that's what network analytics needs to get to. And so today I would say there's a lot of washing. Right? Everybody sort of talks about network analytics. I'm sure SolarWinds talks about network analytics, but I don't think anyone would sort of say, hey, SolarWinds, not to pick on SolarWinds or anything like that. But Google and SolarWinds are not the same kind of product or whatever it is, right? But that's really where it needs to end. So hopefully that answered your question.
Yep, thanks.
All right. So okay, let me talk about. These are the problems, and then from a solution side, the way we looked at it is, okay, well, what's needed is not just more raw data. If we just simply took the NetFlow data and just displayed it, that's really not, what this is about. Again, what's needed is the analytics, the summary, the prediction, recommendations, and so on. WAN dependent, again, detecting changes and detecting incidents and correlating it with specific interfaces or pointing to service providers or interfaces as being the problem. That's an important aspect of, and I'll show you some of that too. The minute-by-minute correlation of WAN data with applications and users or applications and sources is an important aspect of it. We actually sort of have this notion of cloud sourcing, and I'll talk about this more actually as the last part of the presentation, where I talk about some of the work we've done sort of looking at across customer data and like Apple data and Cisco data. That's pretty interesting on this front. But another side of cloud sourcing, using data from multiple environments, is for application identification, right? So the places where we have span port data, there we can use signatures, we can use DNS, we can use all sorts of things to dynamically figure out what the app ID or the application is. But how about places where people are just sending us vanilla NetFlow, like 5-tuple information? What can we do there? Well, we can use the information that we've gotten from all the other environments and actually tie that in and say, oh, based on the other information, we can say what the destination IP is mostly like, or most likely to be. The destination IP and the destination port maps to this application based on the data that we have. And so that's sort of another, just a side benefit that comes with this. But it comes from sort of growing a product in the cloud and tying together information there.